Okay, in this example from lesson 9, this is problem number 8, and they give us this table of data here about baseball players and the breakdown of their hits as singles, doubles, triples, or home runs. And the question they were asked in number 8 is, what is the probability that a randomly selected hit was made by Babe Ruth given that it was a triple? So one of the first things that you're going to want to do in this type of problem is to sum all of the columns. In other words, add all these numbers up in these columns here, and in this column here, and in this column here, and then also do that in the rows. So add these numbers along the rows here, here, and here, and here, and also you'll want to get a grand total. So I just went ahead and did that, and here's what it looks like. So this number 8,468 is just the numbers in this column summed up, and the same thing with these here and here. And then these numbers, these first 4 numbers here in this last column are just the row sums. I just added up these 4 numbers here, and I got 2,873. So then this last number right here is the grand total, and you can get that by either just adding these numbers up here or adding these numbers in this row up, but don't do it twice because you'll double count. So and that is one way you kind of check your arithmetic, is if you add these 4 numbers up, the column sums, and add the 4 row sums up, they should both come out to be the same. In this case, 12,348. Okay, so on to the problems that they want us to talk about. 8, what is the probability that a randomly selected hit was made by Babe Ruth given that it was a triple? So they use the word given in there, so we're talking about a conditional probability. So I'm going to just make some notation here. I'm going to let B be the event that a randomly selected hit was made by Babe Ruth, and T be the event that a randomly selected hit is a triple. So that will just make the notation a little bit easier. So what we want is that conditional probability. What's the probability of B given T? And according to the formula for conditional probability, that would be the probability of B and T. This LibreOffice that I'm using changes the word and to the symbol for and. So that little circumflex there, that caret or whatever you want to call it, just think of that as standing for the word and. So it would be the probability of B and T divided by the probability of T. So now let's go and figure out what those things are. So we want the probability of B and T. So that would be the probability that a randomly selected hit was made by Babe Ruth and that it was also a triple. So we would go over here and look. Right, here's Babe Ruth, and Babe Ruth hit 136 triples, right? So those would be the hits that are made by Babe Ruth and that are triples. So the probability of B and T would be 136 over the grand total of 12,348. Then on the bottom, we want the probability of that the randomly selected hit was a triple. So if we look at the table here, we see that there are a total of 583 triples, right? That's why we added all these together and got 583. So if I pick one of these hits at random and look at what type it was, the probability that it is a triple is 583 divided by the grand total here. So now to figure this out, all I need to do is to carry out this division, right? And I divide fractions by inverting the bottom one and changing it to multiplication. And then, so here's that step done, and then I would cancel here and here, that 12,348, and then multiply together. I have 136 divided by 583. That would be the probability, and I believe that's as reduced as you could get it. There's no common factors there. So that's number 8. Problem number 9 is very similar. In this problem, they ask what is the probability that a randomly selected hit was a home run, given that it was made by Ty Cobb. So let H be the event that a randomly selected hit was a home run, and T be the event that a randomly selected hit is made by Ty Cobb, or was made by Ty Cobb. And they are asking for the probability of a home run given that it was made by Ty Cobb. So that's what we want to calculate. So again, we go to the formula for conditional probability there. The probability of H given T is the probability of H and T divided by the probability of T. So we go to the table to get our numbers here. First, for the probability of H and T. So that would be the probability that a randomly selected hit was a home run and made by Ty Cobb. So that's this entry right here. 114 home runs were hit by Ty Cobb. So the probability that a randomly selected hit was a home run by Ty Cobb would be 114 right over the grand total. On the bottom, we want the probability that a randomly selected hit is made by Ty Cobb. That's what T is standing for this time, right? And so if we look at Ty Cobb, right, he hit this many singles, doubles, triples, and home runs. If we add all those together, we get 4,186. So the probability that a randomly selected hit was made by Ty Cobb would be 4,186 over the grand total. So again, we're dividing two fractions, so we would invert the bottom one and change the operation to multiplication. Here again, the 12,348 cancels out, and I'm left with 114 over 4,186, and obviously that's not reduced, right, because they're both even numbers. So if I divide both of those by 2, I get 57 over 2,093, and that is reduced to the lowest terms. Is also very similar. Here it asks, would it be unusual for a randomly selected hit to be made by Hank Aaron, given that it was a triple? So just using similar notations, the event, H is the event that a randomly selected hit was made by Hank Aaron. T is the event that a randomly selected hit is a triple. And so same formula, right? We want the probability of H given T. So we would go and look at probability of H and T divided by the probability of T, by the same conditional probability formula. And so the probability of H and T, that would be that a randomly selected hit was a triple by Hank Aaron. So looking in the table, right, Hank Aaron hit 98 triples. So I can find that probability by doing 98, the number of triples hit by Hank Aaron, and dividing by the grand total, 12,348. On the bottom, we want the probability that a randomly selected hit is a triple. So again, we're going to go to where we added up all the triples, and we got 583. So that probability would be 583 divided by 12,848. And again, we are dividing fractions, so we would invert the bottom one and multiply and cancel 98 over 583. And they want to know, would it be unusual for that to happen? So it's probably better off to change it to a decimal, and to 4 places it would be 0.1681 or 16.81%. So about 16-17% of the time that would happen, that if we randomly selected a hit, it would be a triple made by Hank Aaron. So that's not all that unusual, right? It would not happen a huge amount either, but it wouldn't be unusual either. So you would probably say, reserve that word for, say, something down around, that happened 5% or 1% of the time, something in that neighborhood. Also, another way, right, this is sort of a longish way to to do these problems here. One way that you could do it is, if you think about this, is they want to know the probability the hit was made by Hank Aaron, given that it was a triple. So really, you're kind of narrowing down your sample space to those 583 triples that we have here. And out of those 583 triples, right, 98 were hit by Hank Aaron. So you can kind of look at that in a different way without applying this formula. It's not a bad way to think about it, although if you find yourself making mistakes and that sort of thing, you probably would want to stick to the more formal way until you start thinking about that in the right way and getting the right